So we've been going back over the unit circle, and by now you should be able to tell me like the sine of pi over 2, what is the sine of pi over 2? 1. Okay. But what about all those angles that aren't given on the unit circle? They're not in increments of 30 or 45 degrees. How do we find those angles? Well, for those we can use the sums and differences of sines and cosines. Today I'm going to focus on cosine. Okay? The cosine sum formula says that the cosine of angle A plus angle B is equal to the cosine of angle A times the cosine of angle B minus the sine of angle A times the sine of angle B. So some big things to help us remember the cosine formulas is that the cosines stick together and the sines stick together. And for the sum, whenever we have A plus B, we actually take a difference. The difference formula is just like the sum formula. The cosine of angle A minus B is equal to the cosine of A times the cosine of angle B. And for the difference formula, we actually add these, plus the sine of A times the sine of B. Before we move on, let's write down our even and odd identities. Okay. The first one is that the cosine of negative theta is equal to cosine of that same angle but just positive. So the cosine of the negative angle is the same as the cosine of that positive angle. That's true for its reciprocal as well. So the secant of a negative angle is equal to the secant of that same angle but positive. Now for the rest of them, they work like this. Like the sine of a negative angle is equal to negative sine of that angle. So the cosecant of the negative theta is equal to negative cosecant theta. This is true for tangent as well. The tangent of the negative theta is equal to negative tan theta. And the cotangent of negative theta is equal to negative cotangent theta. Okay, so back to what we were doing. We're going to find the exact value of cosine of 75 degrees using the sum formula and the difference formula, just to see that they're the same thing. So whenever I'm looking at the unit circle, 75 degrees isn't there, right? But I can find two angles that add to 75. Okay, like 30 and 45. So I'm going to start off with the sum formula. The sum formula, once again, said that the cosine of angle A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. So the cosine of 75 degrees well, that's the same thing as the cosine of 30 degrees plus 45 degrees. So there's my angle A and B, 30 and 45. So to evaluate this, I would say, okay, that's the cosine of 30 degrees times the cosine of 45 minus the sine of 30 degrees times the sine of 45. Okay, so now to figure out what the cosine of 30 and cosine of 45 and so on, we look at the unit circle. So the cosine of 30 degrees is the x at 30 degrees. Here's 30. The x value is square root of 3 over 2. So I have, this is the square root of 3 over 2 times the cosine of 45. So the x value at 45 degrees is square root of 2 over 2. Minus the sine of 30 degrees. So the y value at that 30 is 1/2. And it has the same, the sine of 45 is the same as cosine of 45, square root of 2 over 2. Alright, to multiply fractions, we multiply the numerators, multiply the denominators. So this is the square root of 6 over 4 minus the square root of 2 over 4. They have a common denominator, so I combine the numerators, the square root of 6 minus the square root of 2 all over 4. Now I should be able to use a difference formula for the cosine of 75 and get the exact same value.
Why can't you?
Okay, so all we need are two angles that, when subtracted, give us 75 degrees. Okay, so look at my unit circle. I'm going to push all this away a little bit more. My two angles that can subtract to 75 degrees, I'm going to use 135 minus 60, because 135 minus 60 is 75. Okay, so I'm using, again, the difference formula, which is cosine of A minus B, it's a minus, is the cosine of A, cosine of B, plus the sine of A, sine of B. That's what we wrote down at the very beginning. So the cosine of 75 degrees can also be represented as cosine of 135 minus 60 degrees. Okay, so I'm going to have to find the cosine of 135 times the cosine of 60, and then add that to the sine of 135 times the sine of 60. Alright, so from looking at the unit circle, see that the cosine of 135 degrees is negative square roots of 2 over 2. And the cosine of 60, so the x value at 60 degrees is 1/2. Oh, I'm sorry, that's negative square root of 2 over 2. Okay, and then plus the sine of 135 degrees. So the y value is positive square roots of 2 over 2 times the sine at 60 degrees is the square root of 3 over 2. Whenever I multiply, I've got negative square root of 2 over 4 plus the square root of 6 over 4. Just like in my last problem, I've got a negative root 2 over 4 and a positive square root of 6 over 4. This is the same thing. Which makes sense because they were both the cosine of 75. I just found them two different ways. Alright, let's run through a couple of examples. Let's find the cosine of 285 using that 285 is the sum of 240 and 45. So as a sum, that would be the cosine of 240 times the cosine of 45 minus the sine of 240 sine of 45. Sorry for my handwriting. I'm trying to write really small. Okay, so looking at the unit circle, 240, the cosine is the x value, negative 1/2. Times the cosine of 45 degrees, square root of 2 over 2. Minus the sine of 240 degrees, so that's negative root 3 over 2, times the sine of 45, square root of 2 over 2. Okay, well that's negative root 2 over 4. And then this would be minus this negative square root of 6 over 4. So this is the same thing as just plus, right? Plus positive. And look, we end up with the same thing that we've had in the last example. Square root of 6 minus the square root of 2 all over 4. Okay, for the second example, cosine of 195, that's the same thing as 240 minus 45. So it's a difference formula, so I'm going to use the cosine of 240 times the cosine of 45 plus the sine of 240 times the sine of 45. We look at the unit circle, the cosine of 240 is negative 1/2. Oh, we just used that. And then square root of 2 over 2. Now I'm going to add the sine of 240. So we've done these numbers. The only difference is now we don't have this minus a negative. It's plus a negative. So it stays negative. Negative square root of 2 over 4 plus negative square root of 6 over 4. So we have negative square root of 2 minus the square root of 6 all over 4. Okay, we can do the same thing with radians. Okay, the cosine of 7 pi over 12. 7 pi over 12 is the same thing as pi over 3 plus pi over 4. Like once you form a common denominator and add them. So it was nice to go ahead and have two angles that added up to 7 pi over 12. So this is the same thing as cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. Okay, so I go to pi over 3 on my unit circle over here. And the cosine of pi over 3, the x value is 1/2. The cosine of pi over 4 is square root of 2 over 2. Minus the sine of pi over 3 is the square root of 3 over 2. Times the sine of pi over 4 is square root of 2 over 2. Because these are the y values at those angles. So, square root of 2 over 4 minus the square root of 6 over 4. Just combine them. Square root of 2 minus the square root of 6, all divided by 4. Alright, I actually think that that's enough examples of this kind of stuff, so we're going to skip this last one.
That's fine.
Okay, given that the tangent of angle A is 15 over 8, and the sine of angle B is negative 5 over 13, and that both A and B are in quadrant 3, we're going to find the cosine of the sum of those angles and the cosine of A minus B, the difference, okay? Now, there are a few steps. The first step is to sketch. You're going to sketch two triangles. Okay, now what quadrant are they in? 3. So we have to keep that in mind. So here's angle A. Here's angle B. Now it says that the tangent of angle A is 15 over 8. Tangent is opposite over adjacent from SOHCAHTOA. So 15, 8. Now, here's why it's important that it was in quadrant 3. Since this is in quadrant 3, what do I know about that 15 and that 8? They're both negative. So whenever they got divided, they became positive. But, yeah, whenever we're labeling them, we need them both to be negative because that's going to affect our sine and cosine that we'll need in a little bit. Okay, the sine of b was negative 5 over 13, so negative 5 over 13. The hypotenuse will always be positive. Alright, the next step is to use Pythagorean theorem to find the missing sides. Now, I'm just going to go ahead and give you this side because you should know how to do Pythagorean theorem. So this would be 17, and this would be 12. These are also those Pythagorean triples.
Is 12 positive or negative?
And this 12 is negative because it's in quadrant 3. Alright, finally, we're just going to do the thing, okay? So the cosine of a plus b, that would be the cosine of a plus b. Remember that that's just the cosine of a times the cosine of b minus the sine of a times the sine of b. Okay, the cosine of a, that would be the adjacent over the hypotenuse for angle A. So that's negative 8 over 17 times the cosine of angle B is negative 12 over 13 minus the sine of angle A, so negative 15 over 17 times the sine of angle B, which was given to us, negative 5 over 13. Okay, now we're going to just multiply the numerators, multiply the denominators. Notice that they both have the same denominator, 17 times 13. So negative 8 times negative 12 is positive 96 over 221. Minus negative 15 times negative 5 is positive 75 over 221. So the cosine of angle A plus B is 21 over 221. Now, finding the cosine of angle A minus angle B, this is actually pretty quick once we've done that. Okay, because look at the formula. The cosine of A minus B is the same formula, cosine A, cosine B, plus sine A, sine B. So all I have to do is take my 96 over 221 and add the 75 over 221. Okay, because we'd already done all these steps. We'd already found all those things. I know that cosine A times cosine B is 96 over 221, and so on. So once I add those two things, I get 171 over 221 for the sum of those angles. Okay, the last thing that we're going to do are a couple of verifications. So I'm going to verify that the cosine of x minus pi is equal to negative cosine x.
Okay, let's do this.
So look at this, though. This looks like the difference of two angles. So this should be the cosine of x times the cosine of pi plus the sine of x times the sine of pi. Alright, x is a variable, so the cosine of x, we don't know what that is. So I'm going to write cosine of x. Pi is not a variable. I can find the cosine of pi. So I go to pi on my unit circle, the x value is negative 1. So that's the same thing as the cosine times negative 1. No, I'm sorry, that's, what am I doing? The cosine of pi is negative 1. Right? We don't just replace the pi with a different number. I was being crazy for a second. Okay, so now I don't know what the sine of x is, but I can find the sine of pi. The y value is 0 at pi.
So wouldn't it just be 0?
So what's the sine of anything times 0? 0. Okay, now I've got the cosine of x times negative 1. Well, that's negative cosine x. So I just showed what I was trying to show. Okay, lastly, at the very beginning of the notes, I told you that the cosine of a negative angle is the same thing as just the cosine of that positive angle. And I can show that using a difference because negative x is the same thing as 0 minus x. Okay, so I'm going to do the cosine of 0 times the cosine of x plus the sine of 0 times the sine of x. All right, the cosine at 0. So here's 0. The cosine is 1. So this is 1 times cosine x. Plus the sine at 0 is 0 times sine x. This cancels. And I just showed that the cosine of negative x is the same thing as cosine of x. Alright, and so all of this was the cosine sums and differences. Soon we'll look at the sine sums and differences.